Hello, this is Brother Cromar from the Math Department at BYU, Idaho, and I'll be covering Lesson 4, which is dealing with probability as well as calculating the mean, the standard deviation, and the variance of a discrete random variable. First of all, let's cover what you may see in the past with probability. For instance, guessing correctly heads or tails. The probability, for instance, of a parent's getting a girl or a boy. Blood type, for instance, A positive or O positive, there's probability that the majority of us have A positive and O positive. Getting brown eyes is an example of probability. Brown eyes is the dominant gene. Rolling 7 in a game of Monopoly. When you played Monopoly before, 7 is actually one of the more common numbers to get. Probability of getting rain on in a picnic. For instance, forecasters, they forecast a 20% chance of rain. And so they use modeling for that, and so therefore there's probability. Winning in Vegas or wherever gambling place in roulette, and for instance, you can guess the correct color, the correct number, and guess it correctly, and then winning $1 million in a lottery, or winning a certain amount of money in the lottery. Now, winning $1 million is an example of a rare and unusual event, and that's something that will, a phrase rare and unusual event, we'll get into more fully in Unit 2 when we cover inferential statistics. Now, there's 3 rules of probability that was discussed in the online textbook. The first rule is the probability of any event must be greater than or equal to 0 and less than or equal to 1. The sum of all probabilities of all possible outcomes must equal 1. And if E represents an event and PE is the probability of that event, then the probability of that event not happening is 1 minus PE, and that's something that's also referred to as the complement rule. Okay, so with these 3 probabilities, here's an example of a probability model. The event of the number of heads from 2 flips, the 3 possible events are 0, 1, and 2, and these are the probabilities I put together. So the question is this a true probability model? Well, it is not a true probability model in this case because the second rule does not apply. If you sum these probabilities up, it does not sum up to 1. Now, if we change it up here, where if we say where I change it to where it goes from 0.15 to 0.25 in terms of the probability of getting 2 heads, if you sum these probabilities up, then the answer would be yes, that those sums would be equal to 1. Excuse me, and all of the other probability rules would apply as well. So for instance, the probability of only getting 1 head and 2 flips would be 50%, and the probability of not getting 1 head and 2 flips is 1 minus 50%, which is 50%, or you could say 100% minus 50% is 50%. Okay, now let me just expand this a little bit here. The next example is the probability of getting some type of color in a M&M bag, drawing a color. So for instance, what's the probability of drawing a brown M&M randomly? And in this case, what you do is you sum up all the other probabilities and subtract 1 from that, and you would get 0.2. What's the probability of not drawing a brown M&M? Well, you can just take this number, 0.2, and take 1 minus that, and you would get 0.8. And then what is the probability of not drawing a yellow M&M? It would be 1 minus 0.2 right up here, which is 0.8. Here's another example, example 4, the number of girls with 3 children, assuming the same likelihood for a boy or a girl. Okay, so here's the number of girls, and here's the probability of each of these. Now, first of all, I left this blank, so that you guys can go through with me the rules of probability. So what's the probability of getting exactly 2 girls? Well, if we sum up the other probabilities, that would be 5/8, and so if we take 1 minus that, the answer would be 3/8. So what's the probability of not getting exactly 2 girls? The answer would be 1 minus 3/8, which would be 5/8, and what's the probability of getting no more than 1 girl? So what we would do is that we can take no more than 1 girl, so if it's either 0 or 1, so we can sum up these 2 probabilities, which is 1/8 plus 3/8, and it would be 4/8 when you can reduce that to 1/2. Okay. The last slide is the mean and the variance of a discrete random variable, as well as the standard deviation. So this is an example of number of heads from 2 flips. The events, here's the 3 possible events of the number of heads, and here's the probability. And to calculate the mean is to take the value of the event times the probability for each of these, and then we sum them up to get the mean. Okay. Now, if we use this as an example, the mean of a discrete random variable, what we would do is we take 0 times 0.25, that would be this first one right here, 1 times 0.5, which would be 0.5, and then 2 times 0.25, and if we add these up, then the mean would be 1. Now, in the next video, what I'm going to do is I'm going to cover the mean and variance of a discrete random variable and how you can do this in Excel.